session and thank the seminar organizers for giving me this opportunity to present some points of using artificial intelligence in the mining industry. I'm Soofastaei, an AI scientist and project leader in Vale. Vale is the biggest producer of iron ore and nickel in the world. We are currently operating mine sites and plants globally, and we are managing large network of railroads, ships, and ports used to transport our products across the world. The mining industry uses AI to optimize processes, enhance decision-making, receive value from data, and improve safety. While there are many benefits of its implementation, it is still very new, and there is much work that needs to go into successful artificial intelligence applications. Planning, research, communication, and change management are all essential foundations for analytics application in mining. The main part of my today's presentation will be about showing a couple of practical examples of AI implementation in mining. At the beginning of this session, I would like to introduce Vale AI Center, our research and development model, foundation, and the scope of our works. And then I selected two successful AI applications in mining and shipping in the field of energy efficiency and logistics. The selected examples currently help Vale to sell millions of dollars monthly. In computer science, artificial intelligence, sometimes called machine intelligence, is intelligence demonstrated by machines, unlike the natural intelligence displayed by humans and animals. From Siri to self-driving cars, AI is progressing rapidly. While science fiction often illustrates AI as robots with human-like qualities, AI can include anything from Google search algorithms to IBM's Watson and autonomous weapons. Artificial intelligence today is properly known as narrow AI or weak AI. It's designed to perform a minor task, for example, only facial recognition or internet searches or driving a car. However, many researchers' long-term goal is to create general AI or AGI or a strong AI. While narrow AI may overtake humans at whatever its specific task is, like playing chess or solving equations, AGI would overtake human at most every mental job. AI technology can increase business productivity by up to 40%, and the number of AI startups since 2000 has increased to 40 times. AI will automate 16% of American jobs, and currently 50% of mining companies are using AI, and 31% of them say that it is their agenda for the following years. This news shows that we will have an AI application revolution in the mining industry very soon. Our company has been active in the field of creative and practical use of AI. According to the latest statistics published by official and international sources, only two mining companies, Vale and Rio Tinto, are on the list of 50 innovative companies in the world. In the meantime, Vale is ranked 19. It is a remarkable achievement for Vale. AI Center has played a critical role in reaching this success. As I mentioned before, I'm leading AI projects in Vale AI Center. In this center, we have a global team focused on advancing the research, development, and application of artificial intelligence across Vale. This center is located in Vitória, a beautiful city in Brazil. Vitória is the capital of the state of Espírito Santo. However, my global colleagues manage the AI projects and developed applications from Toronto, Singapore, Rio de Janeiro, Belo Horizonte, Shanghai, and Brisbane. Our center will act as a focal point where people, technology, and ideas can come together. AI Center works with some key research partners across the world. especially in the United States, Canada, Australia, China, Chile, Sweden, and United Kingdom. Currently, we have research collaboration between universities with a development plan to reach 30 until 2023. The AI Center research and development model starts with business challenges, and we are working on current problems and potential solutions to identify opportunities. In the next step, we set the priority for projects based on the concept of the problem and potential benefits. After making a practical plan for the project and in the heart of our research model, we collaborate with universities, OEMs, and technology developers to find solutions for the business problems. After solution discovery, we try to test different achieved approaches and deliver the validated results to our partners, same as IBM, Deloitte, Accenture, Oracle, and Microsoft, aim to make the final product. The AI Center works closely with business, universities, research centers, manufacturers, and application developers to deliver the final product for different operation groups across the valley. When we complete the project, we will start the sustainability phase to finalize a new product. Then AI Center will look after the developed products for any maintenance, modification, and improvement. There are many examples of AI products developed by Vale with the contribution of our global research partners. Today, I will present two of them. The first one is developing an integrated AI model to improve the energy efficiency of haul trucks in surface mines. And as you know, energy efficiency in mining is an essential topic for the mining industry. A practical solution for this challenge can help the companies reduce their energy costs and reduce greenhouse gas emissions. This project's initial idea came from my postdoctoral research fellow at the University of Queensland, when my research team could make a revolution in using AI products in the mining industry. The developed product has been used in different mine sites in Australia, Chile, United States, Brazil, and Indonesia. The achieved results have been acceptable to continue the initial initiatives and integrate AI applications in this field. In this project, we completed some objectives to reach to the final aim. To identify the key factors driving haul truck fuel consumption, we conducted a comprehensive literature review, and then we studied the related published industrial reports. In 6 months, we had many interviews with operators, supervisors, and managers to complete acceptable practical survey. The results show that we have more than 35 effective parameters on haul truck fuel consumption. To choose the critical parameters, we tested different hypotheses and completed much analysis. Then we used advanced analytics approaches to find the relationship between the selected parameters and haul truck fuel consumption individually. Later, we applied an artificial neural network to predict the truck's consumed fuel when we have involved all selected parameters. We reached amazing results. However, the prediction couldn't solve the business problem. The mine managers were looking for an approach to minimize fuel consumption by optimizing the influential parameters. We applied genetic algorithm combined with the developed ANN algorithm to optimize the critical parameters to increase energy efficiency in surface mines to tackle this challenge. The developed integrated model was a revolution in using AI to solve an old business problem in the mining industry. The developed application could minimize the consumed fuel by trucks and help supervisors minimize queuing time in the fleet and maximize productivity at the same time. We tested and validated the developed AI product in different countries, mine sites with different mine products. These various tests in different conditions helped us to reach a reliable and scalable AI product. The developed model has been used in more than 15 mine sites in different countries. In this slide, you can see the results of using this application in Cerrito and Canta mine sites in Arizona. where we could have improved energy efficiency and productivity. The presented results were a part of my research project at the University of Queensland in 2015 and 2016, when I had a chance to work with Freeport-McMoRan and Peabody Energy to collect data and analyze. Blackwater Mine was another site that we tested or developed model for Caterpillar 777, and the initial results showed 8.3% of fuel consumption reduction and 6.1% productivity improvement. I moved to Arizona to test my model in the Morenci mines, that is a large copper mine, and the results of our developed application have been illustrated in this slide. Obviously, reaching these results, we didn't add any new equipment or change the work plan, was interesting for mine managers. When I joined Vale in 2017, we started work on the validated models to make a scalable product for company. And now Vale uses this application in many mine sites in Brazil, Mozambique, and Indonesia. This slide shows results of using the application in one selected mine site in Carajás. Carajás mine, the world's largest iron ore mine, is located in the state of Pará in northern Brazil, fully owned by Vale. It holds 7.2 billion metric tons of iron ore in proven and probable reserves. The energy consumption indicator here in this application is fuel consumption index. This index illustrates how much diesel should be consumed to move 1 ton of mine material in 1 hour. As you can see, we could reduce the whole truck fuel consumption dramatically in this mine when the productivity increased 5%. It is clear that we could develop a successful AI product to improve energy efficiency and productivity. However, there are other concerns on the site that we need to consider. It means that we are facing integrated challenges. There is no guarantee we can reach the actual benefit when we cover just 2 dimensions of a complex problem with different aspects. Based on this reason, we decided to solve the integrated problem by offering the new generation of whole truck application. In this slide, you can see the high level of design of the integrated idea. We have merged operation, maintenance, fuel consumption, and environment data to fit to the developed AI application. By having this approach, we could reach the optimized value for the effective and controllable parameters. It means that by setting the parameters on the proposed values by the application, you can maximize productivity, minimize maintenance costs, improve energy efficiency, and reduce greenhouse gas emissions to protect the environment. As a simple result, the developed integrated model can maximize the benefit margin. We had to complete an individual study first for each presented group, and then we needed to combine the developed models. For example, for the operation, we had to combine all data information received from operators, supervisors, and managers, collected from fleet management system, road condition monitoring system, installed sensors on the truck, fuel consumption data from the gas station, mine planning, and weather stations. For the maintenance, we have the same story. We need to collect the data from oil laboratories, workshops, and road maintenance report. We gather the data from fleet management system, road conditioning monitoring system, mine plans, gas station, and the sensors on the truck, and oil analysis reports completed by site laboratories for fuel consumption and environment. When all individual models and algorithms were completed, tested, and validated individually, we merged all models to make a comprehensive and integrated model. This new model has 3 main sections: simulation, optimization, and decision guidance. The application can predict the energy efficiency, maintenance costs, operation condition, and gas emissions in different windows for each truck individually and for all fleets as well. The prediction window can define between next 1 hour to next shift or next week. The application can optimize 10 effective parameters to reach the optimum value for operation and maintenance costs in the optimization section. But the heart of the developed application that is unique is decision guidance. This application can work as an intelligence coaching machine to guide the operators, supervisors, and managers online, aimed to have maximum performance and minimum overall cost. A very simple application dashboard, including 3 mentioned sections, as illustrated in this slide. In the first section, the application can predict the truck fuel consumption based on the current conditions. In section 2, with just 1 click, the user can find the optimum values for 10 effective parameters, and also the application can estimate the minimized value of fuel consumption in the ideal condition. In the last section of dashboard, you can select the suggested solution by AI model, and then the application can estimate the cost, benefit, and risk of this solution in different categories such as operation, maintenance, and energy. The guidance system in this application is straightforward, uses traffic light colors to evaluate the offered solutions. Green light means that application confidence is 100% to suggest the solution. The yellow light indicates that the application cannot make the decision individually and it needs a human to help. The red light shows the user shouldn't select this solution. The AI whole truck application has different detailed dashboards with comprehensive visualization capabilities. We developed the application to work on desktop and smartphones. By selecting the date and shift, you will have access to used trucks profile details in the fleet. For example, in this slide, you can see the used trucks on March 23 in shift 3. You can see overall productivity for each truck individually, and also you have access to the name of the drivers. In this application, we used color codes to highlight the energy efficiency of the trucks. The green trucks consume the minimum amount of diesel in the shift. The orange trucks are located in the boundary, and the red trucks consume fuel more than standard. By click on each truck, you have access to the machine's detailed profile. This page can illustrate the truck's general information, consumed fuel in the past, the predicted fuel consumption in the future when truck works in the stable condition. You have access to the list of all operators, supervisors who are managing the fleet. You can see their personal information and access to their work performing in the past and their simulated future performance. We use the same color code to categorize the human resources as well. The different people's color codes can help the user identify the operator's behavior in just one glance. The application can provide more information about the person when you are clicking on their photos. This information is different for drivers and managers. The illustrated information is related to their controllable activities. For example, parameters such as average loading and dumping queue can be changed by supervisors or dispatching operators' decisions. So you can see the plotted graphs for these parameters in this slide here. And you have access to the historical information. But the application can also predict the future information for the parameters individually. Everything that I explained to you was just a side of the coin. On another side, the application plays a role as a mentor to coach the people to have better behavior to reach better results. In this slide, in the top right corner, you can see the list of advice generated by application for selected person. All the presented information that I explained to you in the previous slide for a manager can be generated by the application for a driver with different parameters that are controllable by operators. the parameters such as average truck speed, dumping time, and loading time. At the top of this slide, you can see the predicted fuel consumption for this driver and generated advices for him. Currently, we are using desktop version of this application. However, we are working on the next generation of this application, which can be installed on smartphones. The capabilities of the new generation have been improved by focusing on coaching approach to help people use AI for their performance enhancement. Everything that I presented to you today was just about the hauling operation, but it's clear that the hauling process is linked with the upstream and downstream processes in surface mines. Any change in hauling operation parameters can potentially affect other operations. To tackle this challenge, we recently defined a new project named Mine to Mill to cover 5 operations, including drilling, blasting, loading, hauling, and crushing. This new project has been started by collaboration with Sustainable Minerals Institute at the University of Queensland. The initial idea of this project was published in Australian Resources and Investment Journal. If you are interested to know more about this project, you can download this article from my website or LinkedIn. The second AI project that I would like to introduce today is one of the exciting initiatives that we are leading in Singapore for Vale Shipping Strategy team, titled Vessel Movement Tracking. Vale has more than 1,800 voyages every year to move mine materials from North and South America to Southeast Asia. This project aims to model the global vessel movement and predict their commercial availability 1 month in advance. The freight cost is the main part of Vale's total mine product cost. A company that needs to transfer their materials from America to Asia by massive vessels, any predicted information can help the shipping chartering team make better decisions and dramatically reduce the shipping costs when we pay billions of dollars every year to transfer our materials. The vessel market is unstable. The related information needs to be collected from different internal and external resources. There are many variables, including satellite data, port lineups, brokers' data, and emails, and etc., to create our insights and predict the market movement. We made an automated data collection system to gather information from websites by web scraping, from emails by NLP, and use complex AI algorithms to predict the market. We saved millions of dollars last year by using the first generation on the developed AI application. This slide shows a summary of developed AI product outcomes that are categorized in 3 groups: 360-degree view of vessel movement, 30 to the 40-day prediction of future vessel trajectory, and a comprehensive dashboard. The users have access to the live dashboard to monitor each vessel's current situation and estimated destination for each ship individually. There is much detailed information behind these small bullets that you can see on this screenshot, and the user will have access to them with just 1 click. The application has different capabilities. For example, you can select your vessel and you will receive notification by email and SMS if the vessel's condition is changed. The application will automatically be updated every hour, and also the user can refresh it manually. The application can produce different reports by demand. This slide shows another screenshot of the application dashboard. Having a sentiment barometer can give straightforward advice in 1 glance to the user to start the chartering process or wait to have a better market in oncoming days. There are different graphs show the vessel supply and demand conditions in the market in different periods. You can also make your modified graphs and tables presented in the results. Okay, at the end of my presentation, I would like to introduce an innovative platform established specifically for mining researchers and managers to share their ideas and experience in the advanced analytics and digital transformation in mining globally. This platform aims to create a community of researchers in AI and advanced analytics to provide an opportunity for further collaboration in future digital mining projects. You can also keep in touch with each other on the websites, groups, and forums and be informed about the latest research. Please join us to start a fantastic journey in mining industry.
Thanks a lot, Dr. Ali. We've gone over time with that presentation, so we won't have any time for questions, but you've made it pretty clear where people can reach out to you and ask you more questions and find out more about the products.